All right, welcome. So today we're talking about trigonometric identities. So we're going to start in 5.1 with the Pythagorean identities. Okay, so the Pythagorean identities, we've actually mentioned one of these already. Okay, so if you have a triangle, okay, if you have a triangle, let's make it a little bigger. Okay, and you have an angle here of theta. Okay, and then let's say this is, let's call it y, I don't know, this one x. Let's call this h. Okay, we know that x squared plus y squared equals h squared. This is for a right triangle, by the way. Okay, and if we divide that by h squared, okay, if we divide h squared through here, then we're going to get x over h squared plus y over h squared equals 1. Okay, so once we do that, then we can sort of imagine this x over h, that's going to be the cosine of theta. So cosine squared of theta plus sine squared of theta equals 1. So that's the most important identity, I would say, in trigonometry. Okay, it's one of the most used ones that you'll ever have. Okay, now we can also, for example, we can divide this by, say, cosine squared. Let me make that in black. So if we divide this by cosine squared of theta, then we're going to get 1 plus sine over cosine is tangent. So tan squared of theta equals secant squared of theta. Okay, and that one also we use quite a bit. Okay, and we might also have taken this and we might have divided it, say, by sine squared of theta. So if we divide by sine squared of theta, we're going to get cotan squared of theta plus 1 equals cosecant squared of theta. Okay? So these are sort of the 3 Pythagorean identities. We use those quite a bit in this class, okay? And also not just in this class. If you're going to be doing calculus, then you're going to see these things quite a bit, okay? So let's start looking at identities. So what an identity is, it's an equality that you have to prove. Okay, so you have to take one expression and do something to it to make it into another. Okay, so an example is, let's say, number 30, and we have sine x minus cosine x times sine x plus cosine x equals 1 minus 2 cosine squared of x. Okay, so now how were we going to do that? Well, we're going to start from one side and make it look like the other. Okay, so we're going to start from this left-hand side. Normally, we start from the more complicated side and make it simpler. But sometimes we do the opposite. So, and who knows, who's to say which side is more complicated, right? Who am I to say that? Well, we're going to start here from the left-hand side. So if we multiply this out, so we're going to do, that's going to give us sine squared of x. Oh, I should have the same variable, so this is actually a x there. Sorry about that. So back to this. So here we're going to have sine squared of x. Now this is actually a difference of two squares. So it's actually just going to be like, this is a plus b times a minus b equaling a squared minus b squared situation. So the left-hand side here is going to be sine squared of x minus cosine squared of x. Okay, now we're going to take the first Pythagorean identity. Okay, and one of the things I like about doing my work on here is I can do this sort of game. So I'm going to take this identity. Let's make it in a different color. Okay. And due to this identity, what I can do is I can replace my sine squared of x by 1 minus cosine squared of x. Okay, so 1 minus cosine squared of x minus cosine squared of x equals, and then we get the other side, of course, 1 minus 2 cosine squared of x. Okay, all right, now, all well and good, but this is not how problems look in MyLabs Plus. So let me take a look. Let me show you how a couple problems look in MyLabs Plus. Similar. Okay, so real quick, let's take a look. 1 plus sine of theta times 1 minus sine of theta. How are we going to do this? So we're going to take a look at each answer and ask, does this give us the right thing? So the first thing I'm going to do is I'm going to go ahead and write out how I would do this without MyLabs Plus. It's always a good idea to do that. So again, this is a difference of squares situation. So this is 1 minus sine squared of theta, and then that does equal cosine squared of theta. So I'm just going to look for that answer. Nope. That's sine squared of theta minus 1, close, but nope. 1 plus sine squared of theta, also close, but no. Here we go. D, that's the right answer. Okay, so if I had that one here, that's what I would give as my answer. Okay, all right. Let's do another one, if you needed to see this one again. Okay. And let me point out that MyLabs Plus see number 1 on the last page of these notes. Okay, so that'll tell you how it looks in MyLabs Plus. Okay, let's do another one. Let's do number 40. Okay, number 40 says, let me see here, 1 over 1 minus cosine x plus 1 over 1 plus cosine x equals 2 cosecant squared of x. Okay, so again, we're going to combine these things together. So the first thing we're going to do, we're going to decide which side we're going to simplify. I'm going to simplify the left-hand side. It looks more complicated, and that's just how I approach these things. Okay, so first thing I'm going to do is I'm going to combine the fractions. Common denominator of 1 minus cosine x times 1 plus cosine x, which is, of course, 1 minus cosine squared of x. So I'm going to have 1 plus cosine x over, let me write it this way, 1 minus cosine x 1 plus cosine x plus 1 minus cosine x over 1 plus cosine x, 1 minus cosine x. Okay, so here I'm using the common denominator, okay? If I cancel those, I have the original thing. Again, here, if I cancel those, I have this original thing, okay? So all I'm doing is I'm taking my common denominator, 1 minus cosine x times 1 plus cosine x, and I'm writing my old fractions in terms of the new denominator. Let's make this all a little bit, give myself a little more room. That ought to do it. That ought to do it. Okay. So now, okay, excuse me just a second. Okay, now I'm going to go ahead and combine these things. So these have the same denominator. So the cosine here and that negative cosine are going to cancel. So I get 1 over, and I'm doing that multiplication. Okay. Now this is 1 over, oh, let me write it same side. Sorry, that's bad form to write it on a different side until the end. That's 1 over sine squared of x, and then 1 over sine squared of x. Wait a second, my bad. The cosines canceled, but the 1's added to give me 2. Poof. So 2 over sine squared of x, and then that equals 2 cosecant squared of x. Okay, so that's our form. Now, again, like I said, this is going to be number 2 on the last page. Okay, it's going to be similar, so let me go ahead and go to that last page. And we're going to go ahead and do this one, which is very similar. Okay, very similar. So now, same steps. We're going to go ahead. I'm going to skip some of them because we've seen them already. So this is 1 plus sine theta plus 1 minus sine theta over 1 minus sine squared of theta. Okay, so that's just like the first 2 steps that I did. And then that's 2 over cosine squared of theta, which is 2 secant squared of theta. Okay, so let's see which ones of these work. Okay. Now, one of the things that I sort of I have a little technique about multiple choice questions. Okay, specifically, anyways, multiple choice questions. It's not enough to know you have the right answer. You should also know that the other ones are wrong. Okay, so this is a perfect example because the first one looks just like what I wrote. Okay, here, that's the third step, or that's, oh, see? Exactly, this is wrong. Okay, this is wrong. I almost thought that was the right answer, but it is wrong. Here, okay, that's this step. Well, I could have had that, but that's fine. This, yeah. Oh, no, that's wrong. Okay, third one. 1 plus sine theta, 2, nope, that's definitely wrong. Now, let's see. Process of elimination, D should be correct, but let's just check. 1 plus sine theta plus 1, okay. 2 over 1 minus sine squared of theta, I'm good with that. Okay, that's basically in between here and here. 2 over cosine squared of theta, that looks like D. Okay. 3 is similar. No, we'll pass on 3 now. Okay? All right. I'll see you all in the next page.